So if you could be thinking in Austria there what question you're going to ask or what comment you're going to make. I'm going to ask Joe's table first of all. Have you got a comment or a question or observation or?
Yeah, afternoon everyone. Is this working? Yes.
Yep.
So we've had quite a broad discussion. We've got a wonderful mix of people here from primary all the way through to research level. So we've had some comments around the interactive whiteboard effectively causing a lack of pupil interaction with technology because teachers are beginning to pre-prepare PowerPoints and things with their wonderful interactive whiteboard and sort of disabling the children from actually touching anything anymore. We had lots of discussions, but the other point to make is that idea about technology becoming very obsolete very quickly and teachers just losing patience with being able to use technology at any level. And the fact that particularly at primary you have an IT coordinator who's probably no more experienced at keeping that up to date than I am. And so there's a struggle there with trying to keep up to date and use things that are relevant and enable children to have some insight into curriculum and structure. Is that okay?
Yes, thank you, thank you. Luke, do you want to, can you pass that? And I should have reminded you to stand up and say what your name is, so I'm being terrible at this.
Yes.
I just, in addition to talking about what we talked about at the table, I just wondered if you'd like to respond to Joe's comment about the whiteboard in the light of the conversation that we just had.
So we discussed that we think perhaps something might have been lost in the move to the whiteboards, and we spoke positively of the idea of being able to watch the journey of the lesson as they would have in Japan, of what's happened. And it was also pointed out that maybe we can have more dynamic use of space, so maybe we can keep the opportunity for children to share their different representations and solutions, but also have place for teachers carefully choosing representations of their own thinking and showing those on the whiteboard. So,
Thank you. So with respect, those two things could both be about any subject, couldn't they? So has anybody got a comment or a question which is particularly about that that level of was it Kay Stacey's framework at the changing the mathematics level? Did anybody discuss anything at that level? Douglas, where's Douglas gone? Douglas, have you got something to say about that?
Hello, Douglas Butler. I've been running TSM workshops for 21 years, I think, and in that time we trained about 4,000 mathematics teachers to use technology. It takes time. That was Alison's point. You can't do it in the odd hour in a conference lecture. It takes time. So 3 days was fantastic, and they went away really confident about Excel as well as software. I mean, Excel is a very important tool. It really should be built into all the mathematics curriculum because it's such an important tool, but it isn't. So somehow they expected to do it in their spare time. I don't know how. But 2 years ago, we had our last TSM because teachers were simply not being allowed out of school for any time at all. It's getting really difficult. The only time it seems you can run anything now is on a Saturday,
right, Douglas,
which we did.
Can you address the question that I asked you?
I do apologise.
Which was, with due respect, which was, Autograph is an amazing piece of software. How does it change the mathematics experience that students have?
Well, a lot of people ask me, when should you use software like that? And I think it should be done at the end, when you've done your usual drill and practice, you've learnt the topic, and then suddenly you can say, let's have a look and see how the computer does it. What happens if we move this? Or if we're plotting a graph and it stops here, where's it going to go next? You interact with the students. I'm certainly a fan of one computer in the classroom. If you have 30 computers in the classroom, that's a completely different dynamic. They're all learning at their own pace, making mistakes. It's good stuff. They should use their own computers at home, of course. But in my view, the classroom has one big computer.
So you would advocate doing maths in the ordinary way first and then using the computer to illuminate what you've been doing. Celia? Can you use the books, please?
You've got one of your own.
And I'm sure everybody knows who you
Actually,
are.
this is such an old example. I was trying to provoke the table because Marilyn had talked about the ICME study in Vietnam. And if you remember, those of you who were there, that Seymour Papert talked about thinking 10% of the curriculum, given the presence of digital technology. And for the rest of the conference, we all tried to do that. And it's a very hard task. But we did succeed in some ways. And I will give you one example in terms of how you might change the whole. It's not just pedagogy, it's the way you're thinking about the maths curriculum, and that's about mathematical proof, which is incredibly important to all mathematicians. But I remember ages ago Colette Laborde talking about in terms of dynamic geometry, this was before GeoGebra, because you could get yourself convincing pretty well that this geometry, angles in the same segment are equal because you could drag, you shift your whole notion in terms of whether it's true or not to thinking about why. It is the, first of all, and I think this is it sounds like a very small shift, but it's really rather an important shift, because I don't have to worry about at that moment. I can prove it, in a logical form at some point, but I am convinced this is true because I've tried and I've dragged it and I've seen the invariance, and that's what maths is all about. But then I have to really think about why is it true? And by moving and looking at these variables, you can see what the key variance and and I think that's a real major shift. And I think, as both our speakers said, we really should have made a bit more progress in this, I think.
Thank you. Okay, I'd like to bring in Austria first, please. So, could we have Austria, please? Yes. Hi.
Hello.
So you've heard all of that. Would you like to react to it or ask something different?
Yes, I think we discussed the change that you are discussing, and then we have been doing lots of studies, and we always get to the points where the most important agent for change is the teachers. And what we need to do is trying to support the teachers and trying to change their way to technology. And of course, the curriculum and assessment is integrating technology in some ways, but we really need to reconsider that what kind of mathematics needs to be in the curriculum, and also how technology can contribute to this one. So I think more changing teachers' perspective to these inquiry-based or experimental and discovery approaches is one of the key in our projects. But at the same time, we really need to rethink the assessment and the curriculum to be able to do it in the classrooms.
Can I ask
yes.
you to react to what Douglas said? So Douglas said that his preferred thing was to do mathematics in the ordinary way and then to use dynamic geometry in order to illuminate what had been happening or to explore it more. I get the feeling that your model for using GeoGebra would not be that one.
So probably our approach would be very different. So what we are doing projects most of the time is starting from the exploration and discovery, and then getting to the ordinary curriculum or to the formal mathematics what is expected from the curriculum. So we would rather have the students are experimenting either with technology or from some of the physical resources, and then when they are making the connections, we could get to the more formal mathematics in a way. So then that is our approach in most of the projects.
So that's the other way around, really.
Yes.
Okay, thank you. I'm going to come. Last comment, Jeff.
It's Jeff Wake. I just want to make a point that I did a lot of work with dynamic geometry quite a number of years ago now. Sadly, about 20 years ago.
Can you hold it a bit?
And I think that actually using dynamic geometry effectively shifts the way you need to develop conceptual understanding and the order in which you would do that. And I think that's hugely important. So the idea of locus is central to understanding how to construct using dynamic geometry. So I guess, where is that in our curriculum? It's in secondary school. It would come much earlier. Otherwise, you're not going to be able to use dynamic geometry effectively. And so the way you see geometry changes. Equally, transformation geometry, I found totally changed, using it dynamically, totally changed the way I saw the world geometrically. And so I was able to answer problems that were really difficult using Euclidean geometry, using transformation geometry, which I'd never seen before because I'd played with the software. So I think it's not just big ideas like proof, it actually affects the way in which you order the curriculum. And I'm sure that's got some implications for the framework.
Absolutely, and I think that was in a way, that's the instigation for this particular discussion topic, because the team have heard me say this phrase. I think they tick it every time I say these particular words, because I think they've got a bet on. The idea of fracturing the curriculum, that if you introduce dynamic geometry, can you fracture the normal progressions within the curriculum? And I'm sure you can. It's the question of how we capture that, what we capture and how we capture that really vexes me at the moment. So watch out, I'll be talking to you all again. Okay, Zsolt and Austria, thank you so much for joining in, and we'll see you very soon, Zsolt.